Shut up, Fauci. Fauci, shut up. Shut up, Fauci. Fauci. Oh, a fancy meeting you here in space. What do you want, some imagery of the sun? Okay, here's some imagery from Proba 2. Is that cool? Yeah, all right. There you go. Welcome to the Daily Space Weather Show. Congratulations on realizing the channel exists. And, yeah, there's the Proba 2 mission. That's some imagery of the sun there. And you might see some setting active sunspots there over on the western limb. You might see some sunspots over here on the southeastern limb. That area above the Earth scale does not appear to be a sunspot yet, but there might be some sunspots behind that active region there. The real story is responsible for a significant solar uptick. So, indeed, a new series of sunspots formed there on the northeastern limb, just above the Earth scale. That is what's responsible for today's uptick in space weather. And we'll show you some more imagery of that here in a moment. In the meantime, take a moment to press like and subscribe. If you haven't pressed like yet, that's okay, we'll wait. We need your assistance to get the content onto screens. Even though there's a lot of interest in space weather, for some reason, a lot of people are not aware of the most comprehensive daily space weather content in the known universe and the most detailed imagery of the closest star, as you can see here. We even do meteorology segments as a value-added service. Anyway, thanks to our new subscribers on YouTube. Again, press the like button. That's okay, we'll wait. I meant you. Yeah, you. Press the like button, visit the links in the description, and please support the channel, as we would prefer to keep these videos existent, publicly visible, and free for all to view. Today's featured product is not the one I'm wearing. The one I'm wearing is the definition of a certain verb that people still seem to be using. Today's featured product is Do Not Pole Vault the Caldera, our top seller at the Smash-O merch shop. You can find links to the Redbubble shop below this video to find 36 more designs for Smash-O merch. This one features a YouTube URL, and save 25% on all apparel. So get yourself all set up for fall and winter, perhaps with some Do Not Pole Vault the Caldera merch. Again, 25% off all apparel at the Redbubble shop. Other ways you can support the channel would be the Amazon shop. Today's featured product is The Liquid Sun, A Coming Revolution in Astrophysics by Alexander Unziker, talking about the possibility that the local yellow dwarf might be made of condensed matter and not gaseous plasma. Amazon.com/shop/SmashoMash is also linked below this video, so check that out. Another paid affiliate /sponsor link is our Hemp Lucid shop, also linked below this video, right there conveniently in the description. So if you're about to re-up your CBDs or your mushroom gummies, or perhaps your stress, immune, or focus stacks, save $15 still on immune, stress, and sleep stacks from the Hemp Lucid shop. Another one of our paid affiliate /sponsors. Thanks to everybody who's picked up merch and increased the probability that these videos will continue to exist, remain publicly visible, and free for all to view. The ultimate way to support the channel is to become a member of the Smash Team. So thanks to the Smash Team, these videos are brought to you in part by Gold and Silver Smash Team members, also by Smash staff and I at massive personal risk and expense. SmashoMash.com/Smash Team. There's a bronze level. That'll cost you $0 a month. There's a silver level. It's $2.99 a month, and there's a gold level that's $9.99 a month. There's even a gold annual paid-up subscription that's the best value, as it includes complimentary merch. smashomash.com/SmashTeam, the official subscription services site of the Smash News Network, least busted name in news. And here's some more imagery of the closest star for you here. We'll spend a brief moment taking a look at the SDO intensitygram, and you'll see this new beta class sunspot. It's at least beta gamma class forming right over here in the northeastern limb. It has formed rapidly, and it has been responsible for a series of C-class flares. Here's a colorized magnetogram. This depicts yesterday plus today, so it is September 29th and September 30th to date. And pardon the lateness of this video, we had some stuff to do this morning. Continuing on to volcanic coverage. I want to know what's erupting. Suwanosejima is erupting. It's producing a 6,000-foot ash plume. Flight level 100 over Mount Mayan on Philippines. On Luzon Island, there's a 10,000-foot ash plume over Luzon Island. Ibu on Halmahera there, continuing to erupt, producing about a 10,000-foot ash plume there at Mount Ibu as well, between 2,100 and 2,800 meters, drifting to the northeast. Semeru also producing a 15,000-foot plume of volcanic ash over East Java. Dakono also on Halmahera exploding, flight level 070. Popocatépetl now back on the list. As it explodes, it's producing a 19,000-foot ash plume over central Mexico. That's a bucket list volcano for me. Flight level 190 over Popocatépetl. Fuego in Guatemala exploding, flight level 150. Nevado de Ruiz exploding, flight level 220. That is located in Colombia, by the way. Two Ecuadorian volcanoes, Sangre and Revenador, producing a 21,000-foot ash plume and a 15,000-foot ash plume, respectively. 23,000-foot ash plume in Peru over Sabancaya as Sabancaya explodes. It's a flight level 230. And Villarrica also continuing to erupt with some faint emissions there over central Chile. Earthquake activity has been moderate over the past 24 hours. There are the past 90 days. And these are the quakes of a 5 or greater magnitude for the past 24 hours. First on the list is a 5.2 at Papua New Guinea, as we continue to see the most activity here in the western Pacific. So there could be some foreshocks happening there. Who knows? Any earthquake can be a foreshock. That 5.2 occurred at 16:51 Universal Time yesterday afternoon. Then there was a 5.2 in the middle of the North Atlantic, right at the tri-plate border of the North American, African, and European plates. That 5.2 occurred at 19:05 Universal Time yesterday evening. Then South Sandwich Islands had a 5.2 there. Back on the map, South Sandwich Islands, that was at 22:36, that 5.2. And then 0:30 had a 5.8. That was the largest quake of the past 24 hours, I think. South of Australia there, west of Macquarie Island, at 0:31, that 5.8. And there ends the list of 5 and greater magnitude quakes. Here's some more imagery of the closest star. Here we've got some composite. Here showing 211, 304, and 171 angstroms. 2 species of ionized iron and the 304 angstroms ionized helium wavelength. We do see some filamentary activity there. Those are filamentary collapses, I think, as we didn't really see very much coronal mass ejection activity at all. Those brightening events down here, those look like Hyder flares. Filaments collapsing back down toward the chromosphere. So we'll take a closer look at those a little bit later in the video. When we look at plasma filaments, there's 304 angstroms. You'll be able to see some of those filaments indeed looking like they're collapsing there, causing those minor brightenings. And here is the 10.7 centimeter radial flux. It is now at 155 solar flux units, up a bit marginally from yesterday. It might continue to climb here It does depend on what that new sunspot group does. So there's the 1-year graph of the radio flux and the sunspot number. Sunspot number is the red line there. Radio flux is the black line. Again, radio flux now at 155 solar flux units. And it looks like NOAA is forecasting a little bit of geomagnetic unrest on October 2nd. That is, I believe, from a coronal hole high-speed stream. We don't see any indication that there are any more coronal mass ejections headed this way, so by process of deduction, NOAA is forecasting a coronal hole high-speed stream to show up sometime around midday on October 2nd. That would be Monday. Next, the past 4 hours of Earth's magnetic moment from space, and we are seeing geomagnetically calm conditions here. This 4-hour video depicts magnetohydrodynamic pressure, and there was an instrument switch there in the past few hours, I believe, which is what caused that. That could be erroneous. Keep in mind there are 2 different spacecraft measuring the solar wind at Lagrangian point 1, and that solar wind data is used to create this. This is the space weather modeling framework. It uses many different variables. If you want to read about the variables used there, just click the Details tab on the Geospace Magnetosphere Movies page. You'll have a link to the space weather modeling framework. You can even download the software and view it yourself if you like. The past 4 hours of Earth's magnetic moment from the ground are next. It depicts magnetic flux density at the surface level, obviously. And we'll probably see a downtick there as well in the expectations of ground magnetic perturbations. Again, geomagnetically calm conditions. KP 2.33 is the current planetary K index, which for you new viewers out there is an average of global geomagnetism. So calm conditions. And now looking at the real-time solar wind. Pretty unremarkable there for the past few hours. And what you're seeing here is an instrument switch, not a sudden drop-off of the solar wind. Again, there are 2 spacecraft. That is the measurement from the Discover. That shows about 6 protons per cubic centimeter for the density. The ACE only showing about 2 protons per cubic centimeter, and even lower in the past hour or 2. So the ACE spacecraft there showing only 1 proton per cubic centimeter, very diffuse solar wind at a nominal solar wind velocity there, just over 400 kilometers per second. Again, pretty unremarkable here. Like we said yesterday, no new CMEs headed this way that we can tell as far as looking at the available coronagraph imagery. Next, looking at magnetic data, here are our GOES magnetometers. And just keep in mind, folks, the GOES 16 and GOES 18 are in a geosynchronous near equatorial orbit. They're at a very high altitude. Their altitude is like 23,500 miles. They are measuring from just inside Earth's magnetosphere. And you can expect to see fairly smooth curves here until perhaps a coronal hole high-speed stream comes, and I would tend to agree with that forecast for coronal hole high-speed streams. We will get to coronal holes here in a minute. First, let's look at some additional magnetic data. Here's our top view ecliptic plane field plot. And I am thinking that we are going to see a sunspot rise in the southeast based on what we're seeing here. If we're only seeing that new sunspot rising in the northeast, the South Pole current sheet should be arriving here a little more quickly, but it's not. So I suspect that there is an active region there behind the southeastern limb with a new sunspot. So we'll see how that forecast plays out in the coming 24 hours. There's the current situation. Sector boundary crossing here might arrive before tomorrow's daily space weather video. I suspect it'll be very close to the sector boundary crossing. That's that area right here where Earth will snap into a South Pole current sheet in the coming, within 36 hours, I would expect it to arrive at Earth. Next, our line of sight field plot. Here the sun's B field is depicted in blue, polar fields in red and green for south and north respectively, and the gong magnetogram depicting the photosphere magnetism in grayscale. Now coronal holes. And we've been very detailed documentation of the solar cycle 25 progression. And this is how you watch the progression via coronal holes. So, current situation is mostly North Pole coronal holes here facing Earth, but a couple South Pole coronal holes about to rotate into view here in the southeast as well. Let's take a look at coronal holes here in 211 angstroms. So here is the coronal hole system that we are expecting to see a high-speed wind from on Monday. Might be a little bit late, might be late in the day Monday or maybe early in the day Tuesday. You can expect to see a density spike by midday on Monday, perhaps. Density increases in the solar wind density do precede coronal hole high-speed winds. It's a very distinctive signature when coronal hole high-speed streams do arrive. So that brings us to sunspots. And the sunspot number here has indeed come up a little bit there. There's the Royal Observatory of Belgium. Current sunspot number here, about 125 sunspots. And here's our flare probability monitor. At this moment, the two most likely places for flares are going to be down here in the southwest, but especially up here in the northeast. These sunspots have already produced a bunch of flares, and they're looking magnetically complex enough to produce some large ones, especially when they're in such close proximity to the limb. Let's move to some more imagery here from SDO. We're going to zoom way in. There's the SDO continuum in grayscale. Great view of those rapidly forming sunspots. Those did not rise, folks. Those formed spontaneously after that area rose. You can see them in their full formation there. We're also seeing a little bit of growth in this sunspot. So, a little bit of a solar uptick there. And let's move on to solar flares, energetic particles, and so forth. So first, the GOES proton flux. No spikes in that. No solar energetic particle events here for an extended period. As far as X-rays, indeed a significant uptick here in X-rays. Now the background X-ray flux is up to about C1.3. And was that most recent flare in M class? Looks like about as close as you could possibly get. It was a C9.6. So pretty decent sized flare there. Let's take a look at flares from 94 angstroms. Yep, so that flare was indeed from the northeastern limb. So there is a possibility of significant solar flares right in the center of the solar disk as well. This new sunspot here that's just recently grown, that one also does harbor the kind of magnetic fields associated with large solar flares. There are a lot of plasma filaments as well, so we are talking about a nearly 100% chance of coronal mass ejections, which could indeed be earthly directed. We'll cover it once they occur, and they will. Anyway, let's take a brief look at what's overhead. This is what's overhead Lehigh Valley, Pennsylvania. Mars just rose. Yeah, Mars. And by the way, it's a terrible idea to inhabit Mars. There are no resources there, and it's really far away. Could you imagine going to a place that takes 10 months to get to? I mean, for me, it's depressing to go to some place that takes 10 hours to get to. So going to a place that takes 10 months to get to while being exposed to possibly fatal doses of radiation and then 10 more months to get back to Earth does not exactly sound favorable to me. What do you think? I think we'd be better off trying to colonize space than trying to colonize Mars because, again, no resources there, no breathable air. You got to bring your own everything. It seems like just an idiotic idea. Just an absolutely idiotic idea, trying to colonize Mars. So stupid. So stupid. People are like, oh, we gotta leave the Earth. There's not enough room for all the people. Just ridiculous. Anyway, here's our solar system forecast. Here's where things are today. We'll advance this 1 week. That is where things shall be on October 7th. Today's astronomy photo of the day is the harvest moon over Tuscany. You can view that yourself at apod.nasa.gov if you like. apod.nasa.gov. And let's move on to coronagraphs. So it has been chill as far as coronal mass ejection activity. Barely any of it. Don't expect that to continue, especially with the uptick in sunspots, the uptick in the likelihood of solar flares, and all of those filaments. Filaments either reposition themselves, they collapse, or they eject. Sometimes they do all three, sometimes they do just two of the three, but there are lots of filaments facing Earth, is my point. So those are yesterday's frames. We do have some missing data from the LASCO C3, unfortunately. Here's a C2 and the C3 together. Please note the time and date stamps there. We will show some custom videos. First, we'll show Stereo A. So that's the SOHO mission there, located at Lagrangian point 1. The SOHO LASCO C2 on the left in red, C3 on the right in blue. Pay attention to the time and date stamps. Again, there's a bunch of missing data from the LASCO C3. Anyway, we'll show Stereo A as well. Again, it has been very calm as far as CMEs in the past 24 hours. There is the stereo. Let's bring those back. Difference imagery is on the right. Raw coronagraph is on the left. And that CME that you see there in the northeastern limb, that is not earthly directed. That is actually behind the limb, so that is nowhere near planet Earth. Next, we'll show our custom coronagraphs before we move on to filaments. And there you can see that CME out of the northeastern limb. Again, it is behind the limb. You can't even really see the event that caused that. But that does raise the possibility that there are more active regions just behind the northeastern limb. So we could see another solar uptick coming here in the coming days. Fingers crossed for that. In fact, that's a forecast. Expect to see an uptick in solar activity in the coming days. You might notice this huge suspended filament up here. That is an indication of active regions as well. So there is some strong magnetism there hanging out behind the limb. Magnetism is the force that allows those plasma filaments to be suspended that way. So we're going to get to filaments next. First, let's take a quick look at SDO 193 angstroms. Well, I mean, this does show filaments. That is yesterday plus today, September 29th and September 30th to date. And let's move on to the ground-based El Teide, Spain observatory. Once again, that is a lot of filaments. And the one we just named yesterday looks like it is getting unstable. So, over a dozen large plasma filaments on the Earth-facing portion of the solar disk. We'll show the grayscale imagery as well to show prominences. And we only named one of these, so this one right here, that is at the hashtag name that filament. That's known as the Pierre-Marie Robitaille filament. So the author of 40 Lines of Evidence for Condensed Matter, the Sun on Trial, Liquid Metallic Hydrogen as a Solar Building Block. That is, by the way, that paper turns 10 years old tomorrow. So if you haven't read it, you should probably read 40 Lines of Evidence for Condensed Matter, the Sun on Trial, Liquid Metallic Hydrogen as a Solar Building Block. as it is the key to rewriting cosmology. And if you want to name filaments after living people, join us over on Twitter. Follow the hashtag #NameThatFilament. Thanks to our new Twitter followers. And before we get to bonus features, here are the past couple of hours from the GOES 16 SUVI. So just a quick recap. Multiple spots here capable of producing large flares. This area down here looks like it is producing a flare right now. This area right here. And of course, this new complex sunspot group right here. In fact, the entire eastern limb is a flare watch zone. So that's the past couple of hours. Let's move to our bonus features segment, starting with the satellite's community dashboard. And we only see some minor surface charging hazards there in the central Pacific. Not likely to cause major communications errors there, as low-energy electrons build up on the surfaces of spacecraft in a minor fashion. Surface charging hazards in the central Pacific. GOES electron flux here expected to rise even higher, and I'm not so sure about that one. But that's the past 3 days of radiographic measurements by the GOES 16 and GOES 18. Here's a one-year chart to put it in context, and NOAA is forecasting for this to get way up here. There's a forecast. NOAA expecting a significant electron storm there at the next update. Again, not so sure that's going to happen, but no major argument either, so we'll have to see what happens there with respect to NOAA's forecast. So here is we're going to show the layer of the atmosphere where it's measured, the F layer of the ionosphere. One slice of the thermosphere right there at about 300 kilometers of altitude. And here's the F layer's vibrational frequency. And things are looking pretty normal here. Really nothing to write home about in the ionosphere. Here's the anomalygram depicting anomaly in megahertz from the 30-day median. We show it daily on the channel. You never know when there'll be a signal that shows up in the data. So we've been showing all of this for years. And that's what happens in science, folks. A lot of times you end up with answers to questions not asked. So who knows? There could be some kind of a signal that we're data archiving here that we don't even know about. One of the many benefits of creating daily space weather content. So there's the latest image. That's 1330 universal time for the ionogram raw data in megahertz. And there is the anomaly in megahertz from the 30-day median for that same time, 1330 universal time. And here's our ionosphere nowcast. It depicts the total electron content anomaly, the maximum usable frequency and anomaly, and the usable frequency and total electron content raw data. So that's sort of a new feature, the ionosphere nowcast. So that's what's going on. And hopefully you weren't concerned about the apocalypse, because none of this stuff looks scary in any way. It looks totally normal. Next we'll move on to the total electron content. That's the free electrons from ground level up to your GPS satellite level. And there's your total electron content forecast. Electrons fairly organized here. They're pretty much right where you'd expect them to be. Nothing to write home about there. We'll also show the anomaly over North America, and there are some anomalies there, some high electron counts over places like Mexico. We'll let it play through one more time before we show the latest high-res imagery. Actually, around the Mississippi Valley, some high electron contents. So, but those were fleeting and not major. Anyway, here's the latest intensitygram and latest magnetogram. First, we'll look at this new sunspot group. Might be a second sunspot group rising there in the northeast and the southeast. And that is a magnetically complex sunspot group. It is Beta Gamma Delta class. That's the classiest class, by the way. Beta Gamma Delta. Oh, all right, we might have a new sunspot rising there. And there might be a number there. I'm not sure. Might be a little too early to tell. Anyway, here's your full disk rock back. Let's briefly look at these sunspots as well. That one is Beta Gamma Delta class, and that one there is also Beta Gamma Delta class. Nice. So anyway, several areas that could produce large flares, and it's time to move on to meteorology, a value-added service from the Smash News Network, least busted name in news. Once again, if you enjoy the content, don't forget to press the like button. Don't forget to visit our homepage at smashomash.com. In 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. No, you can certainly hire the Smash team. Right there is the link. And again, the best value is the gold annual paid-up subscription. It includes complimentary merch. It's almost like getting 4 months for free, and here comes meteorology. And we're going to start out with some really controversial stuff here, folks. Oh my God, look at this. Dear God, look at that. You know what that map depicts? Time to get spooked. Look at all the carbon dioxide down there. 438 parts per million. And look at how little carbon dioxide there is up here. Only 404 parts per million. Oh my God. Dear God. The world is ending, folks. It's clear. It's clear from this map. Oh, geez, look at this area up here. Wow, what are plants going to do? Look at the 457 parts per million up there. That is some serious atmospheric gas in that area. Yeah. Carbon dioxide, it's one of the things you can track on nullschool.net. If you want to be spooked, of space and Earth, you know, there's all kinds of ways to be spooked, folks. So there you go, carbon dioxide map. Oh dear God. Anyway, here are the surface winds of the eastern world. Shout out to our viewers from the east side Earth. Depicted there. There are your surface winds. Several lows there on the map, including one southwest of Australia, also one northeast of Philippines, and south of the Aleutian Islands is a third strong low there. On the east side, here are the jet streams of the east side, blowing backwards there over the equatorial area north of Australia there and the northern Indian Ocean. Here are the jet streams of the central world. Shout out to our viewers from the central world. That's Africa, Europe, and the Middle East. Here are your surface winds. Denizens of the central world. Several lows down there south of Africa, and one in between Ireland and the southern tip of Greenland. Shout out to our viewers from the west. There are your surface winds. Some heavy winds here blowing through the Drake Passage. So keep in mind, folks, the Drake Passage is a really weird place. The Drake Passage is a small area where the Atlantic and Pacific Ocean try to reach static and thermal equilibrium. There's water sloshing back and forth through there all the time, and look at the winds. That looks like a bad time to be sailing the Drake Passage. Anyway, surface winds of the west, and there are the jet streams of the west. Some very cold air being blown clear down to Mexico from British Columbia. Next, it's a humidity map. Yeah, I figured I'd show something different today. I don't know, humidity map. There are the driest and wettest parts of the world. Cheers. That's surface humidity. And I think it's relative humidity, by the way, if you're wondering. Well, it's certainly not 99% of the atmosphere water, so it must be relative humidity. Relative humidity, folks. Anyway, here are clouds and fog over the Americas as we zoom in closer and closer to the lower 48. I've got some dense fog advisories over large portions of the U.S., which we'll get to here. A lot of fog on weather.gov's map. Weather.gov, here is the key to show you what some of those weather alerts might mean. Those are too many counties to cover. Weather.gov, head there yourself. You're probably able to access a website if you're viewing this video. Next, some forecasts. First, it's the jet stream forecast. And you can see that huge bend in the jet stream injecting cold air all the way down. That is a 72-hour GFS jet stream forecast depicting the 250 millibar winds. Ta-da! Next, our temperature anomaly forecast in degrees Celsius based on the same model. The GFS 72-hour temperature anomaly forecast, again in degrees Celsius. Next, pressure and precipitation forecast, the same model, the GFS 72-hour. And if you saw our video yesterday, we talked about flooding coming to New York, which was coming true as we made the video, and indeed it did come true. You'll find all kinds of news headlines about it. Some snow there coming to the northern Rockies in the next 72 hours. 72-hour GFS pressure and precipitation. And let's don't forget GFS 72-hour total accumulated precipitation forecast in inches. There you go. Ta-da! Heaviest rains there coming to Texas. Some areas they're expecting like 5 inches of rain in about 3 days. Next, lightning. And the heaviest lightning has been indeed in Wisconsin, cheese country. And do we have any terrestrial strikes? Indeed we do. Southwest of Wausau, there is certainly thunder rolling in there, severe thunderstorms there, moving rather slowly. That's your real-time lightning map from lightningmaps.org. And let's close this mother out with the U.S. Doppler, the clouds and fog, and the water vapor. Some heavy precipitation there in the northern Alaskan Peninsula. Again, that storm moving across Wisconsin there, moving quite slowly on its way toward Canada. There's your clouds and fog map. And here is your water vapor map. We've got quite an impulse here of dry, massive air. See, this is a relative high pressure zone. This is a relative low pressure zone. And this high pressure zone is causing a great pulse there, but it's also causing huge pressure gradients and precipitation happening up here in the North Atlantic. Anyway, here's a recap. U.S. Doppler radar shows vertical motion in the air column. Shortwave radiation shows clouds and fog even when it's dark out. A bunch of low clouds there over the East Coast, I can see. Yeah, lots of fog on the map. And last but not least, water vapor. That will clear things up when your Doppler is unclear. Thanks for tuning in to the Smash News Network, Least Busted Name of News. We remain surprised that you've found the channel with the pathetic state of censorship on the internet. Shut up, Fauci. I'm going back to the bunker. We'll see you soon. In the meantime, may that solar wind be at your back. I'm going back to the bunker again. Whoa!